To finish off the, I guess the last week of the neuromuscular system, and we're going to start by talking about different types of muscle contractions. And so this will be kind of a review, but we're going to go into a little more detail than what we did in our introductory physiology class. So here are the four objectives that we've got here. So when it comes to muscle contraction, there are really two main types. We got isometric, and then we've got isotonic, but with isotonic, we can break that up into eccentric and concentric. Okay, and so both of those are a type of isotonic contraction. So when we think of isometric, what that means, iso is constant, metric is length, so the muscle is at a constant length. So this is like something that happens when you do a wall sit, a plank, just while you're sitting here watching this video. That would be an isometric contraction. There's no muscle movement, but your muscles are contracting, because if they aren't, then you'd be a floppy mess on the floor. Like, that's always my go-to there. All right, and then we've got isotonic. So iso, again, is constant. In this case, not metric. We'll fix that real quick here. So not metric, but tonic equals tension. All right. So tonic equals tension, so isotonic equals constant tension. So sorry about that little snafu there. So there are two types of that, so eccentric and concentric. And we're going to get into specific, or what the specific differences is between those two, although all of you probably already know that. And so an example of this would be a bicep curl or a bench press or something like that. Wherever you've got muscle moving, that's going to be an isotonic contraction. So we've got a concentric contraction, and this is where the muscle itself is shortening, okay? And so you're producing force, all right? Muscle shortening, producing force, and so the biceps during elbow flexion. And it's important to note that you've got to know what's going on with the joint angle. So usually the joint angle is decreasing. We're going against against gravity. And so biceps during elbow flexion, quads during knee extension. And then we've got eccentric. And with eccentric, also a type of isotonic contraction, but in this case, the muscle's lengthening. And in this case, you're not generating force to move, but you're actually resisting the force. Okay, and you can actually generate more force with an eccentric contraction than you can with a concentric contraction. And we're going to talk about that later with something called the winding filament theory. So an example of this would be your biceps during knee extension or your quads during knee flexion. Now, it's important to know that when your muscles are contracting, you've got agonist and antagonistic muscles, right? So here we've got, if it circles, there we go. We've got our biceps there, and we've got our triceps here, right? Now, when we're doing a bicep curl, we're going to activate our biceps, but we're probably actually relaxing or inhibiting our triceps. And then conversely, when we're doing elbow extension, our biceps are actually trying to resist that force, and so it's the one that's kind of supporting it, preventing it from dropping on your toe. And so this leads to something called reciprocal inhibition, right? Every muscle has an antagonist. So quads have the hamstrings and vice versa. The triceps have the biceps and vice versa. The flexors have the extensors. Those are antagonistic muscles. And so for movement to occur, one set's going to be activated and the other set is going to be inhibited, inactivated, or at least less active than the others. If they're producing the same amount of force, so if your quads and your hamstrings are producing the same amount of force, there's no movement, and then you have an isometric contraction. Okay, and so when we're doing a bicep curl, we're using our biceps, we're contracting our biceps, and we need our triceps to relax there and to not generate as much force. Okay, and so that's constantly going on whenever you've got movement.